Hey there, my name is Katz, and this is going to be Precalculus Section 2.4. Before we get started, quick shout out to Ava, Maddie, and Elliot. You guys rock.
Alright, we're going to start with secant and cosecant because I think they're actually the easiest, and I'll show you what I mean. So, let's graph the general form of sine. Right, so first thing you do is you go up k units and put a horizontal line to indicate where k is. Next thing you do is you go over h units and you drop a point where h is. Next thing I suggest you do is figure out the period. Whatever that is, you go to h plus period and drop another point. Then cut this in half, figure out where a half period is, and also figure out where your 3/4 and 1/4 period sections are. Now at this point, if you're graphing sine, the general pattern for sine is you plop a point at 0, you plop a point that is 1 amplitude up, you plop another point at 0, and then you plop a point at 1 amplitude down, and then you plop another point at 0. Now, here's the cool thing, and this is what makes cosecant and secant so easy. Everything we just did is the same whether you're graphing sine or cosecant. The only difference from here on out is what we do with these points that we've dropped, and I'll show you what I mean. If we're graphing sine, what we do is simply connect the points. And that's it. That's our sine graph. Now, if we're doing cosecant, what we do is wherever there's a 0, so here, here, and here, we put an asymptote. So what that is just go vertical dotted line, like that. And then for cosecant, again, you go to the same points you already put down, here and here, and then you just spread out towards the asymptote lines that you drew. So the beauty of secant and cosecant is the first 90% of graphing the graph, it's all the same. It's the same k, it's the same period, it's the same little tick marks, it's even the same major points. The only thing that changes is once you do with those points once you've got them down. Alright, moving on to cosine and secant. So, same thing as before. Now with cosine, as you may recall, we are going to put our first point 1 amplitude up from the k line. Then we go to the k line, then 1 amplitude below, then back to the k line, and finally ending where we started at 1 amplitude up. And again, these are amplitude. Now, if we were graphing cosine, all we would do at this point is go ahead and connect the points to form the cosine graph that you're probably familiar with. Now, with secant, same as we did with cosecant, the first thing we do is we put down asymptotes on the 0 points. So the points that are on the k line, I call those 0 points. We're going to go ahead and drop asymptotes. And now, the beauty again is that secant shares these same points with cosine. So we can go to these very same points, and then all we do, like we did before, is just spread up or down towards the asymptotes we just drew. And that's it. So again, same for sine and cosecant. The first 90% of the problem is the same. It's the same k, same h, same period. We're even going to put down the same points. The only difference is at the zeros we put asymptotes, and then our other points we spread up or down from there. So literally that is all you need to graph secant and cosecant. Now just so you can kind of see it in action, I'm going to do a couple of problems from the homework. So again, the first thing I always do is I put down the k line. So the k is 2 in this case, so I'm going to go ahead and put down that k line. And now we look for h. h is 1, so I'm going to go to 1, and I'm going to drop our h right there. Now we need to figure out period. So period equals 2 pi over b, which is 2 pi over 6. The pi's cancel. 6 times 2 is 12, so 12 is our period. So this graph is going to go from 1 all the way up to 1 plus 12 is 13. Halfway in between those is 7. Halfway in between these is 10, and halfway in between those is 4. So we have our beginning, quarter period, half period, 3/4 period, and full period. So now what I'm going to do is ignore for a moment that it's cosecant. Let's just assume it's sine. So I'm going to go ahead and drop my sine points right now. So sine starts here. Our amplitude is 3, so I'm going to go 1, 2, 3 and drop a point up there. Then back to 0, and then 1, 2, 3, drop a point down here, and finally back up to 0. Now, this is the first point at which it deviates from being a sine graph. Since it's cosecant, what we're going to do is put asymptotes at the 0 points. So where the points are on the k line, I call those 0 points. You're going to put an asymptote at your 0 point. And then these other 2 points, all we do is spread up and down towards our asymptotes. And that's it. The first thing I always do is find my k line. We don't have a k line, so our k line is just going to be 0. Next thing I always do is go to h. So we have a plus pi. So our h is actually going to be in the negative direction. So I'm going to go ahead and drop a tick at negative pi. Now I figure out our period. Period equals 2 pi over b equals 2 pi over 1/4, which is 8 pi. Okay, so that means we're going to go from negative pi all the way up to negative pi plus 8 pi is 7 pi. Halfway between those is 3 pi. And then our quarter points are at pi and 5 pi. So we've got our 5 points. Now we can go ahead and drop our major points. So secant is the opposite function from cosine. So normally we would start up here, but since it's a negative amplitude, we reverse everything. So instead we go amplitude in the negative direction, drop a point there. Then cosine goes back to 0. Then it goes up to amplitude, then back to 0, and then down back to where we started. Now again, same as before, everything we've done so far is just the same as if it had been cosine. Now this is where it finally becomes a secant graph. So first thing we do is put asymptotes on the points that touch the k line, those 0 points. And then the rest of our points we simply spread up and down towards our asymptotes. And that is all. All right, let's talk about tangent. So the first thing you need to know about tangent is that the period is half of what it normally is. So normally the period is 2 pi over b. With tangent, the period is just pi over b. Now let me show you the general shape of a tangent graph. At 0, tangent is 0. So drop a point there. At at 1/4 period, tangent is 1 amplitude up. At half period, you put another 0 point. At 3/4 period, you go amplitude down, and then we end right where we started at 0. Now, if you've watched the earlier section of the video, you know that these are the same major points as a sine graph. Do you recognize that pattern? We go k line, 1 amplitude up, k line, 1 amplitude down, k line. Now the only thing different about tangent, again, is that the period is half, and then of course it's what we do with it. So here, where it touches 0, you put the middle point. You put an asymptote. These others, you simply connect them like that. That's it. That is your tangent graph. Now, once you know tangent, cotangent's actually really straightforward, and I'll show you how that works. Now, the cool thing about cotangent is it uses the same major points as tangent, which uses the same major points as sine. So we're going to go ahead and put the same pattern of points down that you saw us put down with our tangent graph. But again, the difference is what do we do with it? So with cotangent, you start and end with the asymptote. And other than that, you just come from up high and go down real low, just like that. And that is how you do cotangent. So to wrap up this video, I'm going to do a couple examples of graphing. I'll do a tangent and I'll do a cotangent so you can see an example of what each of those look like. Our K line is at 2, so I'm going to go ahead and put a horizontal dashed line there. Our H is 2, so I'm going to go ahead and put a tick mark at 2. Now we find our period. So period is, remember, we're dealing with tangent, so it's only pi over b. Pi over b, which is pi over 4. The pi's cancel, and we're left with 4. Okay, so 2 plus 4 is 6. That means our half period is at 4, and our quarter periods are at 3 and 5. Awesome. So now what we do is we drop our sine, we drop the same pattern of points as we would for sine. So we put 1 at 0, our amplitude is 3, so we're going to go up 3, put 1 there, put another 1 at 0, and then we go down 3, and finally back to 0. Now tangent, if you recall, has an asymptote right in the middle. So I'm going to go ahead and put that. And then the rest of it is just connecting these points. Boom. That's it. That's how you graph tangent. So just to complete things, I'll show you a cotangent. And so we're going to do number 4. Put down the K line, which is at 2. So I always put down a dashed line. Now our H is 2, so we go drop a tick at 2. And now we figure out our period. So I'm going to go ahead and do that over here. Period equals pi over b equals pi over 4, which is 4. Okay, so our so 2 plus 4 is 6. That means our half period is at 4, and our quarter periods are at 3 and 5. So now we go ahead, and again, this is a beautiful thing about tangent, is it uses the same, cotangent uses the same pattern of points as tangent and sine. So we put 1 at 0, then we go up in amplitude, then we go back to 0, then we go down in amplitude, and finally at 0. Now, tangent has an asymptote in the middle. Cotangent has its asymptotes at the beginning and the end. And now all we have to do is connect the points. So we start high on the left and then come down low on the right. And that's it. That's how you graph cotangent. So I hope this was helpful. If you have any questions or if anything was unclear, please go ahead and leave a comment down below. I will check the comments later today and tomorrow throughout the day to see if you guys have any questions that I can answer. And if this was helpful, go ahead and like the video. And if you want to see more, go ahead and subscribe. I'll be doing a lesson. Basically every lesson you guys have, I'll go ahead and do one of my own so that you can hopefully get a little bit of help doing some of this problem solving stuff. But anyway, my name is Katz, and contact info is in the description, and I'll see you next time.